Hello friends. In this video in the Kubernetes Simplified series, I'm going to talk about something called as stateful sets. Now before diving into what a stateful set is, let's try to understand the need for stateful sets. Now we all know that stateless applications don't store data. On the other hand, stateful applications require backing storage. Example, databases like MongoDB, Cassandra, and MySQL require persistent storage to survive pod restarts. Consider a database cluster, one is the master and two are followers. Each of the follower communicates with the master, letting it know what it has or what it has not synced. So the followers know that DB0 is the master, and master knows that DB1 and DB2 are the followers and have all the data up to a certain point. In such situations, you need a few things which a regular pod may not be able to provide. Let's see what those are. Number one, a predictable name. You want to start your pods telling them where to find each other so they form a cluster, elect a leader, etc. But you need to know their names in advance to do that. Normal pod names are random, so you can't know them in advance. Number two, a stable address or DNS name. You want whatever names were available in step 1 to stay the same. If a normal pod restarts on the another host, it will get a new name and a new IP address. And lastly, a persistent link between a pod and its persistent volume. Now, if you don't know about persistent volume, don't worry, I'll be making another video dedicated to persistent volumes. Now, if the host where one of your database master was running dies, it will be moved to a new host but should connect to the same persistent volume, as there's one and only one volume that contains the right data for that pod. So if you redeploy a group of 3 database hosts, you want the same pod by DNS name and IP address to get the same persistent volume so that the master is still the master and still has the same data. Followers gets its data, etc. So what does stateful sets provide? It provides stable unique network identifiers, stable persistent storage, ordered graceful deployment and scaling, ordered automated rolling updates. Now we'll see in demo what these all actually mean. Now let's take a look at some of the limitations that stateful sets has. The storage for a given pod must either be provisioned by a persistent volume provisioner based on the requested storage class or pre-provisioned by an admin. Deleting and or scaling a stateful set down will not delete the volumes associated with the stateful set. This is done to ensure data safety, which is generally more valuable than an automatic purge of all related stateful set resources. Stateful sets currently require a headless service to be responsible for the network identity of the pods. You are responsible for creating this service. Now we'll see in subsequent demo what a headless service means. Stateful sets do not provide any guarantees on the termination of the pods when a stateful set is deleted. To achieve ordered and graceful termination of all the pods in the stateful set, it is possible to scale the stateful set down to 0 prior to deletion. When using rolling updates with the default pod management policy, ordered ready, it's possible to get into a broken state that requires manual intervention to repair. As usual, I am on my Docker desktop and I am using a Windows terminal with a Ubuntu distribution. So let's take a look at statefulsets.yaml that I have. So I have defined a service as well as a stateful set. Let's take a look at the service first. So I have defined an object of kind service. The name is Nginx. You can give any name as per your needs. The labels has a label called as app and Nginx. The spec has port defined as 80 and the name as web. Now, as we saw earlier, a stateful set needs a headless service. So headless service is nothing but a service which has cluster IP set as none. The sole purpose of a headless service is to create DNS service records for pods that match its label selector. So instead of reaching pods via services cluster IP, the clients can use DNS to reach the pods directly. This is why a headless service doesn't need a cluster IP. Moving on to stateful sets, I've defined an object of kind stateful set. The name is defined as web and you can name it anything as per your needs. Spec.service name is nginx, which is the same name which you defined above here for your service. Replicas is set to 3, which means there'll be 3 pods when this stateful sets get deployed. Moving on, there are other standard attributes like the match labels, templates, metadata, spec, containers, and stuff. The main attribute that we want to look at is the volume claim templates. So this is what creates the persistent volume claim, and this is the template that is defined in the stateful set. So if you don't know about persistent volume claims and persistent volumes, don't worry, I'll create a separate video dedicated to persistent volume claims and persistent volumes. So what this volume claim template says is it needs a volume which supports access mode read write once, and it's requesting a storage of size 1 gigabytes. Then there'll be a mount point within the container. The mount point name would be www and the mount path would be /usr/share/nginx/html. So this is what our YAML looks like. So let's go ahead and apply this YAML file. Now I'll say kubectl apply-f statefulsets.yaml. Now it has created the stateful sets. Let's see. So STS is a short form for stateful sets. Now as we see, it's creating one stateful set, one pod at a time. So here you see it created the first one after 8 seconds. Then after another 8 seconds, it created the second one. And finally it created the third one. So if you noticed the difference between a deployment and a stateful sets, within stateful sets, it would create one pod at a time. Only after the first one is created, it will move on to creating the next one, and so on and so forth. So that's one of the differences between deployment and stateful sets. Now, if we go ahead and take a look at the persistent volume claims, so we'll say kubectl get pvc. You see there are 3 PVCs created and all of them are bound to the pods. So if you have noticed, all the volume names are different. So each pod within the stateful set gets a separate persistent volume. That's a very important key difference between a deployment and a stateful sets. So in a deployment, if there were 3 pods, all 3 pods would have got the same persistent volume and would have been deployed on the same node. But in case of stateful sets, that's not the case. If you are using volume claim templates, each pod that is created as part of the stateful set will receive a separate persistent volume. Next, let's see how the headless service creates the DNS service records. Now to do that, I have to be within the cluster. So I'll deploy a sample pod which has a dig command as part of its file system, and we'll run that command and see the 3 entries for the pod. So I'll be running a pod called multi-tool, and the image for that is this. You can use this. You can use this multi-tool, which comes with all the Unix related commands like curl, wget, and stuff like that. So dig is also a part of that. So let me run this pod. Now this pod is created. So let me exec into this pod. Exec dash id multi-tool dash dash bash. So now I am inside the multi-tool pod. So let me run the command dig srv nginx dot default dot svc dot cluster dot local. Now you must be wondering what this nginx dot default dot svc dot cluster dot local means. So nginx is basically the name of the headless service. So if you had given a different name, you could use that here. Default is the namespace. So I had used the default namespace. That's why I'm providing the default here. And svc.cluster.local is the default domain which Kubernetes cluster has, right? You can refer any service using this domain name. So let me run this command and show you what the output is. So if you scroll to the additional section here, so you'll see a three domains listed for each of the pods within the stateful sets. So these are the fully qualified domain names for the pods. So what this means is in order for clients to reach the pod, they can directly use this DNS name. They don't have to go via the services cluster IP. So this is the benefit of using a headless service. Now let me exit out from this multi-tool pod. Now let's take a look at what the pods look like. So I'll say kubectl get PO. So there's the multi-tool which we just saw, but if we see there are three pods corresponding to the stateful sets. Actually, let me delete the multi-tool just to avoid the confusion. Kubectl delete PO multi-tool. Okay, now if we take a look at the pods, so there are three pods. All of these are corresponding to the stateful sets that we had. So if you see the naming convention it uses, it gives a unique numeric identifier to each of the pod. It starts with 0. The first pod gets the name, whatever name you had provided in the YAML. It appends dash and gives the first number, which is 0. And subsequent pods gets the number -1, -2, so on and so forth. So let's see the persistent volume claim which the web-0 pod has, right? So if we say kubectl describe PO web-0 and we grep claim name, so we see that its persistent volume claim name is www-web-0. Now what I'll do is let me delete this pod and see what's going to happen, right? So I'll say kubectl delete pod web-0 and I'll say kubectl get PO. Let's watch this, right? So if you see web-0 is container creating. So when I deleted the web-0 pod, it's actually bringing up a new pod and the name is exactly the same as the one we deleted. So web-0. So this is the one of the key feature of stateful sets where the name of the pod would still be the same even if it crashes and a new pod comes up. So the name remains the same. So now if we do kubectl get PO, again there are three pods and the name of the first one is still web-0. Now let's verify if it's still attached to the same persistent volume claim. Now let me run the same command, describe pod and grep claim name. We see it's the claim name is still same www-web-0. So it means that even though a new pod came with the same name web-0, it attached itself to the same persistent volume, which is another key feature of stateful sets. So the pod will always get bound to the same persistent volume no matter how many times it restarts. Let me clear the screen. Now let's take a look at if we do a rolling update or a scale down on a stateful set. So what order will it choose for the pods within itself, right? So let's take a look at that. So just to confirm, let me run the command kubectl get sts, or let me do a pod. So we see there are 3 pods, and if we do sts, there are three. I mean, there's a stateful set named web, and there are 3 pods within it. Now, let's say I want to scale down this stateful set. So let me run a command to do that. So I'll say kubectl scale sts, and the name is web, and the replicas I want to give for scaling down is 1. So right now there are 3 pods running. I want to bring it down to 1 replica. So let's see what happens. And now if I say kubectl get pods, let's watch it. So you see first the web dash 2 went away, and now the web dash 1 is terminating, and eventually we'll be left with the pod web dash 0. Now what happened here, right? So the order which the stateful set selects in a rolling update or while scaling down is it will pick the greatest number first. So in this case we had web dash 2. So it started with web dash 2, it terminated that first, then it moved on to web dash 1, it terminated that, and then it was satisfied with the number of replicas we have, which is web dash 0, and replicas is 1, so it stopped there. So now if we see kubectl get pods, we have 1 running, right? So that's the order which stateful set follows. It starts with the greatest number and it eventually comes down the count. Now let me scale it up again and bring the replicas to 3. So we'll see the two web dash 1 and web dash 2 will be brought up now. So now all 3 should be in a running state. Yep, that's what we see. Now another thing we saw earlier is if we try to delete a stateful sets, there's no guarantee in the order in which the pods would be terminated. So if you have an application where the order of termination matters, it's recommended that you scale the stateful sets to 0 replicas and then delete it. So that way, when you first scale it down to 0, it will follow the standard ordering of starting with the highest number for the pod, eventually going down and down back to the pod number 1, right? And then you can safely delete the stateful sets. So let's try to do that. So I'll scale the stateful set with a replica of 0. So it will bring down all the pods one by one. So as you say, it started with web 2, then it went on to web 1, and eventually it will go for web dash 0. There we see even web dash 0 is terminated now. So if we see the number of pods is 0, if we get kubectl get sts, it will show me the stateful set, but there are 0 pods running. Now we can safely delete the stateful sets. So we'll say kubectl delete sts web, or we can even do a delete dash f and point to the YAML file which we created. So I'll stick to delete sts web for now. So this has deleted stateful set that we defined. Now one interesting thing I want to show you is, let me run the command kubectl get pvc. So even though we deleted the stateful sets, you will see that the persistent volume claim is still present. So the volumes are still present even though the stateful set is gone. So in case of stateful sets, once you deleted the stateful sets, you will have to manually delete the PV, which will delete the volume if you have specified the retain policy as delete. Now, if you don't manually delete the PVC and the volume, you might incur charges if you are running on the cloud. So please make a note that if you delete a stateful set, you'll have to manually delete the persistent volume claim, and the volume would be deleted if you have specified the retain policy as delete. Otherwise, you'll have to delete the volume as well. So that's all I had in this hands-on demo for stateful sets. Hope you liked it. Please give a thumbs up for my video and subscribe to my channel to never miss an update from me. Thank you.